into the basic way of calculating the number of moles because we are currently busy with quantitative aspects of chemical change. So we looked into the mole and on how to calculate the number of moles and what are the key things that we need now to be looking for. So we did few examples on equation number 1, few examples also on equation 2, trying to link the two with one another. So I'm going now to move into the third one, but let's look into the third one quickly before we focus a lot into other things. It says here N is equals to V over Vm, where V is the molar volume of a gas and it is given as 22,4. So I'm going to take this equation, put it into a new page such that now we try and explain it in detail. Remember, the idea also will be, provided we are given 1 and 2, we must also be able to link it with 3. So hence I said everything now fits into us being able to calculate the number of moles. So let's go into a new sheet, and with a new sheet, okay, I'm going to say we are now looking into molar volume of a gas. Molar volume of gases. We are not expected to derive any equation whatsoever, but what we need to know, which is key to us, is N is equals to V over Vm, where now V is just the volume, and now this one, it's molar volume of a gas. So the volume must be in decimeter cubed, and this one now is 22,4 per decimeter mole. So it says to me, if this is the information that is given, when will I now know when to use this equation? The biggest hint is NB. Some information must be given. And what is that information? We are looking for a keyword at STP. This is the keyword we are looking for. So once the examiner says at STP, definitely I can use now my 22,4, because at STP, note this, Vm is equals to 22,4 per decimeter cubed mole. But if this is the case, the examiner must tell me it is at STP for me to apply now this specific equation. If the examiner is not saying at STP, it means they must now give me what? They must give me information of the new molar volume of a gas. So what does this say in terms of STP. The other value that I need to know at STP is the temperature value, which is now T. T must be equals to 278 degree or 273 kelvins. Just want to confirm quickly, but it must be that. So these are two key information that I need to have once the examiner says it must be now at STP. So if it is at STP, the molar volume of a gas will be 22,4. If it is not at STP, then we have a challenge. It means we must be given a new information in terms of the molar volume of a gas. And now the correct SI unit here, it's mole, it's decimeter cubed per mole. Sorry, must be decimeter cubed per mole, decimeter cubed per mole. So if this is how it looks like, can I be in a position of calculating or using this equation to solve problems? Yes, I should be in a position of doing so. So let me have number A as an example for us to use this equation. So this is at number 1A, and then the examiner says to us, calculate the number of moles. Calculate the number of moles at STP. Keyword at STP for 240 centimeter cubed of HE. That is now for helium gas. So key thing that I am looking for, which was now a keyword in this instance, is this information here at STP. So if it doesn't say at STP, there's no way I can use the 22,4. So it must say at STP. Keyword, look for the word STP. If it doesn't say STP, it basically says we cannot use now the 22,4. But that information is given now. It is at STP. So what can I do? I'm saying I'm expected to calculate the number of moles. I have now V, which is 240 centimeter cubed. Because it is now at STP, Vm is equals to 22,4 decimeter cubed per mole. But there's a problem now, or even a slight challenge. What is the slight challenge? The slight challenge is my volume is given in centimeter cubed. So what must I do? Convert now from centimeter cubed to decimeter cubed. How do I do that? I just now divide this by 1000. So I am going to change this now to decimeter cubed. How do I do that? I divide this by 1000. So I'm going to quickly take my calculator, which will be 240 divide now by 1000 is equals to something like 0.24 decimeter cubed. That is the key thing we need now to look for. STP immediately after STP, the emphasis should be on the volume that is given. So the volume was in centimeter cubed, but we want our volume now to be in decimeter cubed. So that is very, very important for us to fully understand and be in a position of answering whatever question the right way. So this one will be easy now because I have all the data that I need. It basically says I must be just N is equals to V over Vm, which will now be 0.24 divided now by 22.4. Then it will give us our final answer, which is 0.24 divided by 22.4, which is equals to 0.011 mole. So this is now the easiest way of doing this one. Key thing was at STP, the SI unit must be in decimeter cubed. So let's add a new page, and this one we are going to try and do it now together. So at number B, they say now calculate the number of moles. The number of moles of 120 centimeter cubed of H2O. And now the examiner says at STP, at STP. What is this STP? It's basically just standard temperature and pressure, but we usually refer to it as STP. So I am going to give you 2 minutes for you to try and complete this one, or even let's make it 1 minute 30 seconds for you to be able to complete it. Send your answer and then we can discuss thereafter. Yes, Ratanang, what's your answer? Okay, let me confirm. Let's do it together then quickly. I have now VM, which is just 22.4. Because of the word STP, I can confirm that. Then I want to calculate the number of moles. I am given the volume 120 centimeter cubed. Then I want it in decimeter cubed. I must now divide by 1,000. 1202 divide by 1,000. It gives me something like 0.12 decimeter cubed. Then it's just NV over VM, which is equals to now N 0.12 divided by 22.4 divided by 22.4. This gives me something like 0.0054 mole, 100%. And because I've used F sort, it will be 1 for the formula, 1 for substitution, and 1 for the final answer. Happy, and this is how it should be done. Let's have a line here to extend the page and say now we are able to use the equation V over Vm. Can we extend it further in order for us to have now linking equation number 1 and maybe equation number 2? Of course we can, because now what we want to be looking for is a point where the examiner says to us at number C, calculate the mass. Calculate the mass of 120 centimeter cubed of NH3 at STP. So the examiner is not asking us to get the number of moles in this instance. The examiner is asking us to calculate the mass of 120 centimeter cubed of NH3 at STP. But there's only one equation that I know that relates the mass and the number of moles. So it basically says this will be the two equations that I need. The reason for that is this one here is the one that will give me my mass in grams. This one here will address now issues of being at STP. So we are basically linking now what? Equation number 1 with equation number 3. So doing this together will be, let me first start by N, which is V over Vm. And I have the volume, which is 120. Converted that to decimeter cubed will give me now 22.4, which will be 0.0054 mole. Then once I have that, I can easily say now N is equals to M over the molar mass, which will be 0.0054. I want the mass, and now I need to calculate the molar mass of NH3. So that is just 14 plus 3 multiplied by 1. Remember, it's M now over 17, 0.0054, and I can now be in a position of calculating the mass. That will be 0.0054 multiplied by 17 is equals to something like 0.0918 grams. This now becomes my final answer. Is there a question on this one, or something that you feel I need to explain? You fully understand. So it's basically taking the basic information we had of using equation number 1, which was this one, and now linking it with equation number 3. So the key issue here is just to check which information is given. So the information given always gives us a guideline on how to approach these specific questions. Fine. So we are happy with the use of n is equals to v over vm. I am going to add a page now and focus on what we call concentration. Let me add a line for the purpose of dividing the page. And now we look into concentration. We look now into concentration. So at 5, we are now looking at concentration. Key thing is we must now be able to define what is a concentration. So concentration is defined as the amount of substance per unit volume. I'm going to write it down. It says it is the amount of substance per unit volume. So let me quickly write it down for you. Is the amount of substance per unit volume. And we say the equation or the SI unit for this one, it's mole per decimeter cubed. And the equation now to calculate this concentration is just C is equals to N over V, where N is just number of moles and V, it's now volume, and it must be in decimeter cubed. And obviously C, it's now our concentration, and this concentration must be in mole per decimeter cubed. Mole per decimeter cubed. Fine. So can I use this in order for me to calculate the number of moles and other things moving forward? It says here now let's make this one 5.1. It says a solution of 200 centimeter cubed contains 0.4 mole of sodium carbonate. Now calculate the concentration of the solution. Calculate the concentration of the solution. Let's write down the information that is given, the data thereof. They want me to calculate concentration, but I am given N, which is just 0.4 mole. I am also given V, which is 200 centimeter cubed. So highlight the information given, the volume of the solution, 200 centimeter cubed, the number of moles, 0.4 of that, and then now calculate the concentration. Fine. This seems to be easy, but there's a key thing that I need to understand. What is that? My volume must always be in decimeter cubed. If it's not in decimeter cubed, then I cannot use this equation C is equals to N over V. I cannot. So for me to use this, it's important that the equation or the SI unit for the volume must be in decimeter cubed. So obviously I must first converting this, divide now by 1000 will give me something like 0.2 decimeter cubed. Then I can further go on and say C is equals to N over V. Remember F sort. What do we do with F sort? We write the formula as it is from the formula sheet. I have the number of moles 0.4 divided now by 0.2. Then I use my calculator. This will be 0.4 divided now by 0.2. This will just give me now 2 moles per decimeter cubed with the correct now what? SI unit. So I'm going to give you 30 seconds for you to digest this, and if you have questions, then that will be a right platform immediately after to think of this. So our 40 seconds starts now. Yes, Ratanang? Okay, so let's move on and take it a notch a little bit higher. Okay, now under concentration as example number 2, they say now calculate the concentration. Calculate the concentration of 4.5 grams, okay, of 4.25 grams of sodium nitrate if dissolved in water of 250 centimeter cubed. So I will give you 5 minutes for you to do this. Remember, send your answer so that I can quickly mark and we know that we are on the right track. Okay, Ratanang, what's your answer? Thank you very much. I have received it. Let's look into the approach. The approach seems to be correct. Let's confirm if everything you have done is okay, but thank you very much. So let's try to mark it together and check if you did it now the right way, but it seems to be 100% correct. Thank you very much, and that's a job well done. So obviously the first thing here will be check the information given. I am given the mass here, and obviously it is dissolved in water of that volume. So what do I need to do? It's going to be again a multi-step type of an approach, because I need now, even if the question says I must calculate concentration, the only equation for concentration, it's C is equals to N over V. So somehow I must first now calculate the number of moles. There's no other way. So for me to calculate the number of moles, N is equals to M over molar mass, because I am given the mass. Then I have my 4.25 divided now by the molar mass. So the molar mass sodium is 23, plus now nitrogen is 14, plus 3 oxygens, and this gives me something like, let me 23 plus now 14 plus 3 multiplied by 16, it gives us 85, and I saw you got this one right at 85. Then the final answer will be 4.25 divided by 85. This will give us 0.05 mole. So when I am happy with this, I can easily say, but now I have my volume, which is equals to 250 centimeter cubed. Now I must convert it to dm cubed. This is just 250 divided by 1000, and then it gives me 0.25, and that will be now my volume in decimeter cubed. Okay, let me clean it up. 0.25 decimeter cubed. Then C is equals to N over V. This will be easy, 0.05 divided now by 0.2, and this will be 0.05 divided by 0.25, and the answer will be 0.2 mole per decimeter cubed. And I am happy because it's what you got. So you did exceptionally well on this one, and it basically says we are now moving in the right direction. So thank you very much for that, and we can easily now proceed. So you will understand why all the basics had to be done. We had to do the basics because of the basics allows us to move to more complex problems. So now moving to more complex problems, we get into this. Now that all the equations we are able to use, which are these 4 important equations. So we need now to link them with what we call the basic Stitiometric calculations. So this is where now I need your full attention. So at number 6, we are talking now, let's say stoichiometric Stitumetric Calculations. So Stitiometric Calculations is basically combining all the information we have done this far. Combining all 4 formulas. And basically what it says is we work from the given to the unknown, or what is the question in this case. But now I need to cross this bridge, because for me to move from the given to the unknown, I need now a new concept which is called molar ratio. Now one will ask, what is this molar ratio? Molar ratio now allows us to bridge the gap between given and unknown. That is important for us to understand. Secondly, where do I get this molar ratio? I get the molar ratio from the balanced chemical reaction. So my reaction must be balanced. If it's not balanced, then I am not going to be in a position of doing this exercise completely or even the right way. What does this mean to me? It means I must have a reaction that I am working with. What is a reaction? A reaction is I must have my reactants, I must also have an arrow, I must also have my products thereof. So let's try and use a simple equation here, which is which is A plus B gives us now AB. So it will be A plus B gives us now AB. So when I look into this, it says to me, is it balanced? That's the first thing to check. Yes, it is balanced. I have only A here, only B there, and then A and B. So the amounts or the number of atoms of A and B are now equal. So what is my molar ratio in this case? I have a 1 here, I also have a 1 here, I also have a 1 here. So all these coefficients, all of them is what now we call our molar ratio. So it will depend on the equation given. If the equation is maybe of this nature, where I have A2 plus B gives me now AB. What must I do in this case? It basically says I must multiply here by 2 and also multiply here by 2. Why? Because I want to have 2 atoms of A. 2 multiplied by 1 will be 2 atoms of A, and now 2 multiplied by 1 of B will be 2. Then I just multiply this by B. So what does that say now? It says my molar ratio now changes from 1 2, 2. But still, because these are my coefficients, this also becomes my molar ratio. So I need to fully understand where am I getting my molar ratio. So what does this mean? This means now at a new page, this means, maybe let me delete it. This means I must be in a position of getting the moles of given, because we agreed that we are moving from the given to the unknown. So it basically says I must be given some information here. But what information is that? It's the number of moles. And how can I calculate the number of moles? Those four basic equations we started with. N is equals to M over M. Another one, it's N is equals to N over NA. And another one, it's C is equals to N over V. And another one is N is equals to V over VA. So I must be in a position of using now each one of them for me to calculate the number of moles. So that will depend on the information that is given. So from the information given, I must be somehow be able to calculate what? The number of moles. But after calculating the number of moles, how do I link that now with the unknown? It means now I must have my molar ratio. So the molar ratio will be the one fully helping me to now get what? The number of moles. Then we get the moles of unknown. So once I have the number of moles of unknown, regardless of the question, it means I must now be in a position of applying the basics that I know. What are the basics that I know? Is that once I have the number of moles, I can calculate mass, I can calculate volume, I can calculate the number of particles, I can also calculate the concentration thereof. So this will say now N is equals to M over M. This is now when I'm expected to calculate the mass. I can further move on. N is equals to V over Vm. Now this is me calculating the volume. I can further move on and say N is equals to N over Na. This is me now calculating the number of particles. So this will depend on the information given. Then I can further move on and say I can calculate now the concentration. So it is always important to check what is it that the examiner is asking for. But what is key? And when do I know that I am going to use now this approach? NB. Look now for a balanced chemical equation. Somehow a chemical equation must be given, and it must be balanced. So for me to apply all this, I need now what? A chemical balanced equation. So I am going to give you 40 seconds for you to digest this, and then we can do an example that relates to this. Ratanang, any question, anything that you want to say? So you are fine. Okay, let's move now to an example where we can apply all this. So applying this, let me divide the page. So applying this, we are going to use a nice example. Here they say, given 4Na plus O2 gives us now 2Na2O. Determine the mass of oxygen that will react with 230 grams of sodium to produce Na2O. So this is the statement or the stem of the question. We are given that information. So they want us to determine the mass of oxygen that will react with 230 grams of sodium to produce Na2O, sodium oxide. So where do we start? First step, check if now the equation is balanced. So I have 4 of Na, 2 multiplied by 2 will be 4 of Na, 2 multiplied by oxygen is 1 or is 2, and then 2 oxygen. So I am happy, my equation is balanced. Now, furthermore, if that is balanced, what information do I have? I can say now, from this slide, somehow I must calculate the number of moles of the given. So what is the number of moles of the given? I can calculate the number of moles of Na. How can I do that? Because I am given the mass, which is now 230, divided now by sodium. I look into my periodic table. That is 23. That is now 23. Then it's 230 divided by 23 is just 10 mole. But this is just the number of moles. It's not assistive. But the rule said, yes, I am going to get the number of moles. So how do I link the number of moles with the molar ratio? very easy. Take note of this. Take note of this. We say the number of moles of Na over the number of moles of the one that is now in question, the one that is the unknown. Which one is the unknown? It's the mass of oxygen. So it means O2 in this case becomes my unknown. So I am relating the number of moles of the given with the number of moles of the unknown. So this becomes now equals to, what is the coefficient in front of sodium? 4. What is the coefficient in front of oxygen? Just over 1. So where did I take 4 over 1? It's the molar ratio from the balanced chemical equation. Thereafter, what is needed now is to have cross multiplication. Then I have 4 n of O2, which is equals to 1 multiplied by n of sodium. Then, but I know this is equals to 1 multiplied by 1 will be 10. Then divide by 4 for me to get the number of moles of oxygen. So dividing this by 10, 10 divided by 4 will give me number of moles of oxygen to be 2,55 mole. So now that I have this number of moles, it becomes easy because the question wanted the mass. How do I link the mass now with the number of moles? Very easy. N is equals to m over the molar mass. So now this becomes 2,5. I want the mass. And what is the molar mass of oxygen? The molar mass of oxygen is 2 multiplied by 16. Then it's m over 32, 2,5. Then cross multiply. Then I get that it's 32. It's 32 multiplied by 2.5 gives us now 80. So m here is 80 grams. It's 80 grams. So I'm going to allow you to think of it and digest it such that now we fully understand how we got about this. So let me give you 40 seconds for you to digest it, and then we can move to another one. Any questions, Ratanang?
In the beginning of the song, you said sodium equals N over mass. Why is it only 1 N? I mean, one is 1 sodium.
Okay, because remember we are given this information here. Let me highlight it for you. We are working with this because determine the mass of oxygen that will react. So it basically says our focus now is on the left hand side. So our focus is only here. So the information that will be given will be for this information. So let's check the question again. Determine the mass of oxygen that will react with, so this is for 1 sodium, only 1 sodium. So that is the reason why we used now the 23 rather than any other thing, because we are only looking into the information that is given to us. So what is given to us is 230 grams of sodium, not of sodium to oxygen, no, to produce this. So before the production of sodium oxide, we want to know how much of this do we need. So that is the reason why we did not focus on sodium oxide. We only focused on sodium, because the only information that is given, the mass that is given, is for the sodium atom. Thank you. That's the reason why now the use of 23 comes in, not any other thing. But one will ask, so what did I do to link up the two? I used now my, let me get a highlighter. I used now my molar ratio. Do you understand how we got this 4/1? Ratanang, do you understand how we got this 4/1? Thank you very much. So if you understand how we got the 4/1, it basically now emphasizes the issue of linking the given to the unknown by use of now what? Molar ratio. So the only way of me linking the given and the unknown is through molar ratio. So you will always have this step where you compare the given as well as the unknown. So you will always have this step here. Let me change a pen. You will always have this step here where now you link the given as well as the unknown. So that step is very key and very important. So I will give you 5 minutes to try and do the next one on your own, such that we know that everything has been covered. Kindly mute your mic while you work on it. So it says here, calculate the mass of oxygen given, okay, 6 given 2K ClO gives us something like KCl plus now 3 oxygens. And then the question says calculate the mass of oxygen that is released. Nope. That is released when 29,4 grams of KClO is heated. It's as simple as that. So let me give you 5 minutes for you to work on it, and then we will quickly discuss together. Don't forget to send your answer so that I can check the work you have done. No problem. Continue then. Just give you 2 minutes for that. Okay, your answer has been received. Okay, let's try and do it together, and then we will mark as we move on. Now, calculate the mass of oxygen that is released when 29,4 grams of KClO is heated. So it basically says this information that we have is for that. Can I calculate the number of moles? Yes, I can. But what is it that I am working with? I am working with this information here. So one mistake that you did, you worked with KCl, and we don't have information for KCl because it is clear here to say 29,4 grams of KClO. This is very, very important. So check the information that is given. So my advice to you will be read the question once, read it twice, such that you clearly see what information is now given to you. So let's do it together as form of remedial to say now, fine, I must be in a position of calculating the number of moles. That is my starting point. That is now my reference. So for me to get the number of moles, what must I do? It must be N, it must be now number of moles N of KClO. That is what I am giving. So I am only going to work with the information that is given. I cannot work with KCl because KCl, I don't have anything about it. Then I say mass over the molar mass. So this now says to me this must be 29,4 over, now I am going to my periodic table, look for K, it's 39, plus Cl is 35,5, plus now oxygen is just 16. Take the calculator, it's 39 plus 35.5 plus 16. That gives me now 90,5. So is equals to 29,4 divided by 90,5. Then 29,4 divided by 90,5 gives me 0.325 mole. 0.325 mole. So these are the number of moles now of KClO. So the mistake you did here was you now starting to work with KCl, and that cannot be correct, because if you work with KCl, it means you are not working with the information that is given. So automatically you get now your number of your molar mass being incorrect, and now the molar ratio also becomes incorrect, because now you are comparing two different things. It cannot be 2/2, it should be now 2/3, because we are working with KClO and oxygen for that matter. So let's now say, after getting this number of moles, what do? I need to link the given with the unknown. What must I do? I must use my molar ratio. What is it that I am comparing? The number of moles of given to the number of moles of the unknown, which is now oxygen in this case. So what is the coefficient of KClO? It's 2. What is the coefficient in front of oxygen? It's now a 3. What is the number of moles of KClO? It's 0.325 divided now by the number of moles of O2, which is equals to 2/3. Cross multiply now, I have 2n of O2, which is equals to 3 multiplied by 0.325, which will mean now that if I multiply this by 3, I am going to get something like 0.9745, and then divide this by 2, because I want to have only the number of moles of oxygen. Divide by 2, then I get my answer as 0.48 7 mole. But these are the number of moles of oxygen. These are the number of moles of oxygen. But I have not answered the question as yet, because the question says now I must get now what? The mass. But I know that N is equals to M over M, which is now 0,487. What is the mass is what I am looking for. What is the molar mass is 2 multiplied by 16. So it's basically this multiplied by 32. Then I get now my mass of oxygen to be equals to 15,60 grams of oxygen that is needed. Ratanang, kindly ask a question to rectify the mistakes that you did in the answer you sent to me.
Also, will I need to run any calculations?
Okay, so it basically says read the question at least 2 times such that you identify the one that is given and you identify the one that is the unknown, such that you can easily relate the two and you don't do the mistake that you did. And also focus more on how effectively can you use now this molar ratio. This is one of the key aspects that majority of learners don't get it right. So once your issue of understanding how to use the molar ratio, believe you me, your chances of getting the Stitiometric calculations correct, you stand a better chance than any other one once you fully understand how you link the given molar ratio and finally moving to the final answer. Because if you check, we are basically using the same principles we used when we started this specific lesson. So the lesson is arranged in such a way that we build towards more complex things, but ensuring that the basics are correct. So when I check your answer here, I am very happy with the basics are there. It was just an issue now of how to use the information that is given. So I'm going to allow you to say something before I can give you a question that I want you to work on your own, such that then we can discuss it later. Anything you want to say? Okay, so I'm going to give you one as part of homework for you to practice with it, and then we will see now how best can we assist one another, even though the class will be done and finished. So feel free to ask any questions, because my key idea here is to assist and help you the best way I can. And remember, immediately after this session, I'm going to send you the PDF notes of everything we did. So it basically says you'll have the notes for you to refer and compare to your answers. So let me give you